Welcome to Python for Nuke 101 and the beginning of your journey to integrate Python into your day-to-day compositing workflow. Before we get into the first lesson, we should get through some quick housekeeping. This is the first week of 10 weeks worth of video tutorials. Each week, we'll aim to tackle a new project and incrementally introduce new concepts and methods as we go. Everyone has a different style of learning, and if you don't know how you learn best, this course will be the perfect opportunity to experiment. If you're watching the lessons and forgetting things the next day, try to read and reread the course notes throughout the week just to keep yourself familiar. Experiment with coding alongside me each week while you watch the lessons. Perhaps stop and start the lessons and give yourself time to fully comprehend what you're learning. I'll also be assigning a weekly challenge at the end of every lesson. These will be designed to test the knowledge you've learned each week, and I highly encourage you to try and accomplish them every week. The best way to confirm that you're learning and improving is by applying your knowledge and creating something without having the support of your tutorial. Each week you should expect to receive the following: a new video lesson just like this one, which will teach you new concepts, a PDF of the course notes I'm using to record the lesson just for you to reference, a .nuke folder which will be up to date with the current and all of the previous lessons' content, a cheat sheet containing simple Python snippets learned, and a Python file containing the solutions to the previous week's challenge. Now let's get into our first lesson. When Nuke is installed and open for the first time, a .nuke folder is created. This is your user directory, so to speak, and where you will interface with Nuke via Python. This lives at the following directory: C users username .nuke. In Windows, the .nuke folder is hidden by default, so I usually find that it's easier to type this manually in the address bar. Although if you're using Linux, you would want to go to home username .nuke, or if you're using Mac, you would just go to users username .nuke. The two most important files we're going to cover in this lesson are init.py and menu.py. Both these Python files are loaded up when Nuke starts, but in a different order. So let's create them here. Right click, new text document. Let's do menu.py. Yes. And another new document, init.py. Okay, cool. Secondly, Python is a modular programming language, and so it's a good idea to keep each new tool we create as self-contained as it can be. It's also beneficial to create custom directories to assist in keeping our .nuke folder clean and tidy, as it can get pretty messy and out of hand as you continually add more items. Let's start organizing our .nuke directory by adding two folders, one for gizmos and one for Python. For Nuke to register that these folders exist, we have to add a couple lines of code to our init.py. Although before we get started, it's a good idea to download some free software to help us with our code. Even though you can write Python directly inside Nuke script editor or your default operating system's text editor, there are way better tools for the job. I like Sublime because it's portable, lightweight, and great for beginners. You can download it from this URL, or I will include this in the course notes as well. So let's open this init.py file and start adding some code. So to add the path, we have to use the nuke.plugin add path function. So let's type that. And to load a custom directory, we have to put quotes in here, do dot, which references the .nuke directory, /gizmos. And we also want to copy paste this and type Python. Anytime we create a subdirectory or even a subdirectory within these subdirectories, we should add the new path just so we can be specific with Nuke and it knows exactly where to look when you're adding new things. Now is a great time to talk about version control. Just like how we incrementally save versions of our Nuke scripts, we want to do the same with our code in case something breaks and we have to roll back to a previous version. There are two different things to help with this. The first being headers. It's a great idea for any Python script that you write to add a header to the top of the file. This should contain a file name, a version number, and the date when it was last updated. In case of any version confusion, this is going to help you identify what is what. But we're kind of getting ahead of ourselves, and we should start with a little bit of fundamentals here. To type a comment in Python, we start our code with a £. So we can type, "This is a comment." Or we can also do a multi-line comment by adding 3 quotation marks and typing, "This is a multi-line comment," and finishing it with another 3 quotation marks. So to create our header, let's create a bit of space at the top here. And I've created one before. So this is what I use in my own personal init PYs. So right here, we've got a file name that matches the file name up here, init.py. We've got a version number, and how I like to structure my version numbers is a major version, a minor version, and then a revision number. So if I were to make a mistake here and then come back and change it, I could change my revision number like that. And also I have the last updated date. So I can come back. I know that I've had a working version on May 6th and just load this one instead if for whatever reason anything goes wrong. And then, as always, it's a good idea to set comments for anything you code, just to make it clear for yourself at a later date or for anybody else who will see your code to know exactly what's going on. Secondly, we should utilize Git. Git is a common resource to help you version control your code. When set up correctly, it allows you to continually develop incrementally improving versions of your .nuke directory and have all your changes synced to any computer using it. There's enough content on Git alone to justify its own course, but for now, let's stay specific to how we can realistically use it within a VFX production pipeline. Because a lot of studios don't allow local software installation or file uploads online to maintain security, we have to do things with a manual upload or a copy-paste. This is not the way Git is intended to be used, but for little effort, we can still take advantage of its version control systems and maintain a portable, up-to-date .nuke directory that we can easily take from studio to studio. To get started, we should create an account on GitHub. If you click the sign up button, and create a username, email address, and password, and we'll continue from here. Once you've got GitHub all set up and you've verified your email address, this is what it looks like from a blank slate. So we want to click this Start a Project button. And the idea here is we want to create a repository that's going to mirror our .nuke directory. So let's name this .nuke. And the description will be my custom tools for Nuke. I would recommend you set this to private for now and create the repository. Once our repository has been created, we want to start by creating a new file. Unfortunately, as I mentioned before, we're not able to upload any files from a studio for security reasons, so we have to do it the old-fashioned way. So let's create a new file. And we can name this menu.py. And we'll scroll to the bottom and commit a new file. And now we want to create our 2 folders to mimic our .nuke directory. So to do this, we have to create a new file. Just like any other file path, we can type in here. So .nuke is our root. We'll start with gizmos / to create a folder. And unfortunately, we can't just commit a new folder. So we'll have to create a dummy file for now. So let's call this temp.txt. And commit new file. And lastly, we have to do the same thing for our Python folder. So we'll create new file, .nuke / python / test.txt, test, commit, back to .nuke. Okay, so you can see that we've got a gizmos folder, a Python folder, an init.py file, and a menu.py file, just as we do in our .nuke directory. You can probably see that we have a few extra files here and a workspaces folder, and this is just stuff that Nuke creates for itself to save preferences and like layouts of how Nuke is set up and things like that, but we don't have to mirror this into GitHub. So next we want to set up our menu.py. So menu.py is one of the last things that loads up with Nuke. This is where we would put all of our preferences from keyboard shortcuts to custom scripts, etc. Whereas init.py is more used for like setting up Nuke as it's loaded earlier. So whenever we want to add a new subdirectory or add some plugins or anything like that. So as we did before, we should add a header. We can copy paste it from our init.py. Oops. And let's just change some things up. So we'll call it menu.py version 1 last updated. Cool. Next, we want this file to be operating system independent. If we ever have to reference a directory structure, each operating system has its own, so we have to program a way to deal with that. To solve this issue, we can add some variables. And a variable is a way to assign a name to the value of something so we can easily recall and reference that value again later. In this case, it's going to be a file path, but it could also be numbers, text, which is referenced as strings in Python, and so on. As we work through future lessons, we'll be creating lots of variables, and this will start to make a bit more sense. Now let's start with a comment to write what we're doing. It's always a good idea to comment your code as you write it for the same reason you'd label nodes and add backdrops in a Nuke script. You want your code to be easy to read and to navigate, so next time you open it or whenever you pass it off to the next person, it's very clear what's happening. So I have a code snippet here. So let's go through this. We're adding a comment to find where .nuke directory is on each OS's network, which is exactly what we're doing. And we're creating 3 variables: Win directory, Mac OS X directory, and Linux directory. The way you assign a variable is you type a name, you type equals, and then you give it a value. If it's a number, it can just be a number like so. But in this case, file paths are just strings, so this is fine. Next, we can make a new variable called dir, and we can set our directory to each one of these variables to get these values depending on where this menu.py is. So if you were to create this at home on a Windows machine, this is correct. But when you go to work, you can just change this to Linux dir and it's going to reference the right directory. But we shouldn't stop there because there's way more potential for automation in this case. What if we're too lazy to even just change this every time we change operating systems? And we can totally make this happen automatically. And to do so, we have to introduce a new concept, which is critical to how Python operates, called modules. Earlier, we touched on how Python is a modular programming language. This means, by default, we only have the core of Python loaded in to work with. This is really cool because it means Python's super lightweight, but when we need extra functionality, we're able to import a new module. There's an overwhelming number of modules, and a lot of the useful ones already come with the standard Python library, which means you can import them without installing anything extra. I will provide a link to further reading if you want to read more about modules and different things you can import in the course notes. So for example, when we're working in Nuke, we're programming with the Nuke module that the Foundry wrote with Python. The Nuke module includes specific functions that have been pre-programmed to do very specific things that we only need to do in Nuke, such as create a node. Because we'll be using it a lot, let's import Nuke into our menu.py by typing import Nuke. Cool. So we're about to dive straight into the deep end and brush over some things you'll probably find yourself doing a lot when you're up to speed with Python. You're learning a lot of things really quickly here, so don't worry if things seem to be traveling at light speed. We'll return to a lot of these concepts in future lessons and future weeks and explain them a bit more in depth then. So we have our first project with Python. How do we get our menu.py to automatically check what operating system we're using and use the right operating system directory by default? The answer lies in the platform module. The platform module is useful for getting specific information about your computer's hardware and operating system. To help with what we're trying to do, the platform module includes a system function, which returns the name of the operating system we're using. We can check the output in Nuke. So to get started, let's open up Nuke and we will type import platform. So here we're importing the platform module. If we hit Control Enter, that will run the code. And this window here is really useful to see any errors or basically whatever's happening whenever you run your code. So now that we've imported the platform module, we can create the system function. So to use it, we have to reference the module platform and type the name of the function, which is system. And all functions end with a open parentheses and close parentheses. Again, this is a concept that we'll dive a lot deeper into and we'll be using a lot in lessons going forward. But for now, let's just hit Control Enter to run the code and see what it outputs. So our result is Windows. Although sometimes when you write code like this, the result doesn't necessarily always get output like this. So I can hit Control open square bracket to bring up the last thing that was run. And let's append this by typing print to the start. So print is a way to basically force Python to show a result. So we can say print hello, and it will print that. Whereas if we type platform.system, it will say Windows as well. So let's head back over to our menu py that we have open in Sublime, and we can do a check to see which operating system we're currently using and set the dir directory or the dir variable accordingly with a simple if-else statement. And an if and else statement is a pretty fundamental thing in programming, but again, we'll really be diving into this in later lessons so you can understand it fully. So as we just learned, to use the platform module, we have to import it. Import platform. This should go above these directories. Anytime you import something, it's always a good idea to have it at the top of the script because code always runs line by line. So if you try and reference anything from the platform module, but you type it up here, it's not going to work. So here's some code that I prepared earlier. So how this is working is it's saying if platform.system, which remember we ran in Nuke and it returned Windows, if the value of this equals Windows, then we want to set the directory to Windows dir, which is our variable up here. If it doesn't, it will go to the next line. So in this case, if the system equals Darwin, which is equal to Mac, if you run platform.system on a Mac machine, this is what it'll output. So if the system equals Darwin, we'll set the directory to Mac OS X directory. Otherwise, if we're using Linux, we'll use the Linux directory. Otherwise, we'll just set the directory to none, which basically means no value. And that's it. So now anytime you use this exact same menu py file, whether you're on Windows, it'll automatically pick up the Windows directory. If you're on Mac, it'll pick up the Mac directory. If you're on Linux, it'll pick up the Linux directory. Pretty sweet. So as I mentioned before, we want to try and keep our GitHub repo up to date anytime we make a change. And this is a pretty good point to save our file, same as the init py. And let's jump back to our GitHub repository. As I mentioned earlier, the correct way to do this would be to set up a syncing of some sort to get these files syncing with everything in your .nuke directory. But again, when you're working in a production pipeline for a studio, you don't have that luxury. So you unfortunately can't make Git operate how it was intended to operate. But what we can do is copy paste text. So if we open our init.py file, we can click this little edit this file icon, and let's just copy this and paste it. It's a good idea to type a description anytime you update it. So we'll go initial init.py file and commit. And then let's go back to .nuke and we'll do the same thing for our menu py, where we'll copy the code, edit the file, paste the code, and initial menu.py, commit. Okay, cool. And now our project from lesson 1 is complete. So anytime you make any changes to your code, and when it's working correctly as you expect, you should upload it to your Git repository. Last thing for this lesson, I want to touch on a topic that a lot of people don't really talk about, and that is how to solve problems. It's important to mention that a lot of programmers don't actually know what they're doing because they constantly have to solve problems they've never encountered before with knowledge from previous, albeit different experiences. Now, there's a direct parallel with compositing too. For example, when we try and key a shot, we start with methods that have worked well in the past, but as you know all too well, that method often only gets us part of the way there, and we have to figure out a unique solution to get the shot done. So going forward, expect your code to error a lot. There's nothing wrong with code erroring. It just means that you've got a syntax wrong or you've forgotten a comma, and even experienced professionals do this. The problem-solving methodologies are going to be the same as compositing. Just as you disable nodes in your Nuke script to diagnose a problem, we're going to be commenting out lines of code to do the same. When you're really stuck, it's comforting to know that someone has already likely encountered the issue you're facing. And in this case, Google is your best friend. And finding the right answers is easy when you know how to ask the right questions. This is a soft skill in and of itself, and you're going to develop it the more you immerse yourself in programming with Nuke. At this point in time, we're at a very, very basic level of Python. We've only written a couple of lines of code, so it's going to be very hard to ask the right questions to find the right answers. But I promise you, as we get further into the course, you learn more about Python and the way it works, and especially the way it works in Nuke, you'll start to get a sense of the types of questions you need to ask to find the answers that you need to find answers to. And that wraps up this week's lesson. It's a very short lesson as we've introduced so many new concepts, so I want to give you enough time to wrap your head around it. And that kind of ties us into the first challenge of Python for Nuke 101. Let's start out the first week with an easy task. Rather than a proper challenge, I want you to implement what this lesson covers and set up your .nuke directory with the folders and both the init.py and the menu.py files, complete with headers, and make it all clean and tidy. Then upload everything to GitHub ready for the next lesson.